This is Advanced Algebra 2. We're going to talk today, 4-8, about Cramer's rule. You're going to see the determinants that we're going to have today, class, are going to be the ones that you will do by hand. Okay, remember the AD minus BC, the cross minus cross business. Okay, we're talking about 2x2 systems. Let me give you the general rule of what this is. Your first line will be in the form AX plus BY equals M. AX plus BY equals M. We'll get to the calculator in a few minutes. My second line will be in the form CX plus DY equals N. That is generally in standard form, generally with the variables written to the left. Generally, you want these to be equal to a constant. Okay? And then from this, what I want to do is define three determinants, and I'll define them with capital D. The first one is the simple determinant of the coefficients of my variables A, B, C, D. And that's why they're named that way, because that's the first one that we need. Okay? The second one is I'm going to represent as D sub X. D sub X. And this one is going to be found by taking the coefficients that are on the x variables, in this case A and C, you take those ones out, and you put the constants m and n in its place. So my m and n go in the x variable column, okay, and then the b and the d stays the same. Notice my brackets are straight. They don't have the little overhangs on the top and the bottom, because a straight line represented in the bracket means to find the determinant of those four numbers, which we can do by hand very quickly. We'll do it in a minute. And finally, we have to name D sub y, which common sense might tell you would be to take the y coefficients out. So b and d are going to come out, and then the constants m and n are going to go in its place, and then the x A and C coefficients are going to stay A and C. Okay? And it turns out there is something very crazy about this. Your solution xy, which you are going to find as a coordinate, okay, as a coordinate, is found by calculating x as d sub x divided by d, and the y is calculated as d sub y divided by d. This is truly, truly amazing that this even works out this way. And it does. I don't know anything about it. I don't know how it was discovered. I don't know if it was invented or developed or what. Obviously, a guy named Cramer came up with it. But it works, and it works every single time, and it's actually pretty fast, especially for those of you that leave your calculator in your locker or run out of batteries or whatever. Let me show you an example, and then I'll take a question from you. Example 1, let me give you a system. My system is 2x plus 3y equals 3, and x plus 4y is equal to negative 1. All right? The first thing that I want you to do is to define all three determinants, and we can calculate them almost in the snap of a finger. My first determinant is my four coefficients, 2, 3, 1, 4. And very quickly, you can look as cross minus cross, or AD minus BC, or 8 minus 3 is 5. All right? What?
Minus 4, or is it times?
No, it's minus 3, right? Because 3 times 1.
So how do you find the determinant again?
Okay, the determinant, as a refresher, okay, if you have a 2x2 matrix, A, B, C, D, is equal to cross, which is A times D, minus cross B times C. So you multiply these two and get 8, right? Minus, multiply these two, 3. 8 minus 3 is 5. Are you with me?
Yeah.
Okay. Now, the other ones are d sub x, which would be take the x variables out and put my constants in. So 3, negative 1 goes here. Okay. And my y variables stay the same, 3 and 4. Okay? So my determinant is, let's see, cross, that would be 12, minus cross 3 times negative 1 is negative 3. And 12 minus a negative 3 is 15. Okay? And my third one is d sub y. I substitute my y coefficients with the constants. So 3 and negative 1 are going to go in the y column. And my x coefficients stay the same, which is 2 and 1. Alright? So the determinant, and feel free, do this by hand, do it in your head, or do it in the calculator. I really don't care. It doesn't matter to me. Okay? It's all the same. Cross negative 2 minus 3. Negative 2 minus 3 is a negative 5. And these numbers are very, very nice. These numbers are very, very nice to work with. Because my solution point is going to be, and you can memorize this, dx over d, comma dy over d. Dx over d, comma dy over d. So dx 15 over 5, which I can put here, comma, dy over d, or negative 5 over 5. So my solution point would be 3, negative 1. Right?
Yes.
Looks good. Was that pretty easy?
Yes.
Okay? Let's try it again for practice, then we'll do a 3 by 3, see where we're at. x2. Let me give you a couple lines here. 7x minus 4y equals 15. 3x plus 6y is equal to 8. Okay? I'm going to do these kind of quick, so keep up with me. My first determinant is the determinant of all the coefficients, 7, negative 4, 3, and 6. Cross 7 times 6 is 42, minus cross is a negative 12. And 42 minus a negative 12 is 42 plus 12, or 54. Good to have. D sub x. Take the x variables out and put in the coefficients, the constants, 15 and 8. 15 and 8 go in the x column. Negative 4 and 6 stay as they are. Cross, this is going to be 60 minus a negative 32, which is 60 plus 32, or 92. I hope this comes out nice. D sub y is going to be, take out the y constants and put in 15 and 8 in the second column. And my x constants go back in, which are 7 and 3. So let's see here. Cross 7 times 8 is 56, minus 15 times 3 is 45, and 56 minus 45 is 11. Okay? And finally, all we have to do is dx over d, comma dy over d. Dx over d is 92 over 54, comma dy over d is 11 over 54. And I think 11 is prime, and it does not go into 54, so that one is good. Somebody give me 92 over 54, math, enter, enter. Reduced fraction is?
46 over 27.
46 over 27. So my final solution is 46 over 27, comma 11 over 54. So the point is this. If your solution messes with a bunch of nasty fractions, okay, it's easy to do this way because you don't really have to deal with the fractions until the very end.
Right around dx, you said 15 times 6 is 60. That's
Oh, wow, okay, whoa, holy moly. Let's take this off of YouTube. 15 times 4 is 60. 15 times 6 is 90 in it. Minus a negative 32. How about 112? Is that better?
I think he deserves points for that one.
Okay, so this is going to be 112 over 54. Somebody give me 112 over 54, math, enter, enter.
56 over 27.
Thank you. 56 over 27. And you still see my point. Fractions don't look very nice. You want to mess with those with elimination or substitution? Not really, because then you got to go back and substitute back in, and it's pretty obnoxious. But here, it comes right out for you. It's very nice. All right? Let me leave this up here so we can refer to it as we go through the next couple problems or two. Okay? X3. think we have a special case or two to deal with. There's another way that we can do this using the calculator. And I'm going to call this an augmented matrix. And your calculator has the term RREF. And we'll be able to find that. I'll show you where it's located in a second. I'm not going to set up the overhead, okay, but I'll just use my calculator to show you where the stuff is located. RREF, and I'll tell you what this stands for. That's a parenthesis, because your calculator puts an automatic parenthesis in the calculator, okay? Reduced, this is called reduced row echelon, ECHELON form. And that's where RREF comes from. Reduced row echelon form. So let's practice RREF. This is entirely done in the calculator. Okay? X minus 3y equals negative 17. 2x plus y equals 1. Question, what are those? Lines. And what do they do? Intersect somewhere at a point, and we're going to find that point x comma y. Alright, turn your calculators on. What we're going to do, and I'm going to do this with you, I'm going to write it down so you can see it first, and then we'll use the calculator to do all the work. I want to store all of my numbers, coefficients and constants all together, right, as one big matrix. 1, negative 3, negative 17, 2, 1, and 1. Okay, and you can go ahead and store this as matrix A. I'm going to do it with you. Okay, so we're going to go second matrix, go over to edit. Question, what is the dimensions of matrix A? It's a 2 by 3. Okay, so I have 2 by 3. Okay, is this, can you see that? Does that look good? Am I holding it in the right spot?
Yeah.
Okay, so let's type these numbers in. 1, negative 3, negative 17, enter. 2, 1, 1, enter. Let's go back to the home screen, hit second quit. Alright, RREF is found under matrix, and then you got to go over to the math tab. So hit second matrix.
You're like out of battery.
I just changed the batteries.
Yeah, I found it.
Okay, well, when it goes out, who cares? Alright, so what we have here is this. Go over to the math tab. Go all the way down. Identity, augment. Don't go to augment. Keep going. It's minus selection B. Is your selection B RREF?
Yes.
Okay. Hit enter, and that brings it out into the home screen, just like this. So what you want to have here is RREF, and then you got to go back and select matrix A and put that in the parentheses. Second matrix, select A, and then hit enter. And what do you get?
1, 0, negative 2, 0, 1.
Here's what you get. RREF of A gives me this. 1, 0, negative 2, 0, 1, and 5. What does this mean? Look at my first row. Is a 1 and a 0. Doesn't this mean 1x plus 0y? Doesn't this mean 1x plus 0y? So it means 1x is negative 2, so I put that right here. And my next line is 0x plus 1y equals 5, so my solution point is negative 2 comma 5.
That is awesome.
It's cool.
So you always just